So, hello all, welcome back to the channel after a long time. And let's see today's problem. This is the problem from DP series, obviously, right now from CSES sheet, and the problem name is array description. So, let's read the problem, what the problem is saying. Basically, you know that an array has an n integers between 1 and m, and the absolute difference between two adjacent element is at most 1. Given a description of the array where some values may be unknown, your task is to count the number of arrays that match the description. So basically, in first line, we are given two integers n and m, and after that, we are given n values that are x1, x2, x3, and xn. And the value 0 denotes that here we do not know what can be the value. But according to the problem, the maximum difference between the adjacent values should be at most 1. So how can we approach this problem? Like if we were not knowing that this is from DP, and basically if this is from DP, then obviously we could have think of recursion. But why recursion? So let's say if we have 4 and 8 here, and suppose these values are unknown to us. So unknown to us means according to the problem here we will have 0, 0, 0, 0, 0. So what could we have thought of, like if we do not know what this problem belongs to DP or recursion based? So we since the difference at most difference between the adjacent element can be 1, so we can write that here it will be 5, then here it will be 7, then here it will be 6, and if one more value would have not known to us like this one, so here we can take 7 or 6 or 5, anything like that, because the difference would have created one only. Here we can have taken 6 or 7. Okay. And if this range is very high, then we could have thought of many numbers like 5, 6, 6, 7, 7, 7, and there could have been many choices. And at this side, if the number we do not know the number, then here also we could have taken 3, 4, 3, 4, different combinations of 3, 4, and similarly on the right side of 8. But since the value of n is very large, 10 to the 5, we cannot apply brute force in this, like counting different ways of counting the this combinations and permutation. So I think you would have been clear with this problem that we can generate any such numbers like 5, 6, 6, 7, then 5, 5, 6, 6, 7. Any combination can be possible. But so we cannot apply the brute force. Now, why we should apply the recursion? Obviously, we will have to do some task repetitive number of times. And since we have to do some task repetitive number of times, we would think of recursion. Like it will call its function more and more times. And since we are doing something more and more times by calling someone, there comes the role of recursion. So from this idea, we will get that yeah, this problem belongs to recursion. Now, once we get the idea, yeah, that this problem belongs to recursion, so we can how we can apply recursion? So let's see. So the only choice what we have is if we have number, let's say x, then after that we can have x plus one or x minus one or x. So we do have these three choices. Okay, now let me write in good handwriting. Suppose at this position we have v. Then at the next position, we have three choices. Either we can have V only, so the difference between the difference will be 0. We can have V plus 1, then the difference between again will be plus 1. and we can have the number v minus 1. Again, the absolute difference will be 1. So we have three choices. If we know the value at this index is v, then the value at index I plus 1 will be v or v plus 1 or v minus 1. So we have been three choices. Okay. So okay, so this can be count as the base. Suppose now let's see the code. So yeah, I was saying that this is how we have taken the um, array value, array, and suppose the value is not known to us, like at that place we have zero according to the question. So we will try every possible value from 1 to m, and we will call the function base. So this function will perform the part of the recursion. Like suppose here we have what this function base is doing. This is basically calculating the answer for us, and we are passing first. We are passing the value zero. That means the index zero, and the value v. That what we require. So at the initial position, suppose we do have v. Then at the I plus one position, we can have v. At the I plus one position, we can have v plus one also. And at the I plus 1, that is the next index position, we can have the value v minus 1. So these are the three choices what I was talking about. Yeah, so these are the three choices: v, v plus 1, v minus 1. Okay, so these three are the possible ways through which we can form the array. And the basic part of the recursion that we should follow is the base case. So here when the value of v is less than or greater than m, that is not considering the question, that is in the question it is properly given that we cannot be greater than m and we cannot be less than 1. So if b is greater than 1 or greater less than 1 or greater than m, then it is the out of range, so we will return basically 0. We will return 0. Now if at that position the value is not known to us, as well as we do not know it is not the value v, it is not under the range 1 to m, then also it is a mismatch. And suppose if we have reached the last index, that is n minus 1, so we are left with one choice only, that's why we are returning 1. I hope it would have been clear to you, and at last we will return the count. That is the answer. And we are taking the modulus m because in the question it has been asked to take the mod value because the answer can be large enough. So this was the basic part of the recursion. In summary, we do not have to do much. There are three possible combination. Either the value can be the v, what value we are taking, or it can be v plus 1, or it can be v minus 1. And we are considering different values of v from here 1 to m. So this was all about the recursion part. Now we have to optimize this obviously. So let's move to the memoization part, like the DP one. So here for for converting recursion to the memoization, we do not have to worry much. Here we have created the DB vector 2D DP, since we are having the two states, and the states are like the index and the other is the value v. So these are the two states. Like at index I, what is the value we are getting? And since we have two states, so we are creating a 2D vector, 2D DB vector. And the transition will be this only: I plus 1, I at I plus 1 we can have v, v plus 1, v minus 1. These are the transition basically. And we are storing this in DP, and if we get some value, then we will return. So memoization is very basic. You can have or solve on your own also. Let's move to the tabulation. Now for converting, basically what the tabulation is the building of the table. So for converting memoization to tabulation, I have discussed in the previous videos also. You do not have to worry much. Like here we are considering the I is going from 1 to 0 to n. So the base case, that is I, when I is 0, the base case is this only. If we have, if we are at index 0, so we can have all the possible combinations of V, and that is the one way. And if we are again at index 0 and the value is known to us, so again we have one way only to consider it. After that, we will build the DB table. We are going from the first index to the last index, and the value of those values which are not known to us can be from 1 to m. And okay, we were counting the ways, that the ways can be v plus 1, v minus 1. So if at index I minus 1, we know the value is v. If at index I minus 1, if we know that the value is v minus 1. And if at the index I minus 1, we know that the value is v plus 1. So we can definitely find the value at index I. I hope it would have been clear to you. There is nothing more challenging in this. Only we have converted the base into this DP, nothing else. And I have told you in the previous video also that the DP vector shows its value at the last. So here, what is at the last? That is the DP of n minus 1. This is storing the last value. So we will basically sum up all this value, and that will be the answer only. What is this? If you are again confused in this, let me show you. Here we were storing the count in this DP. Okay, so here we were storing the count. So this count is what we are storing directly into the DP here. There is nothing much serious. I think I would have been clear to you. It would be much better if you do this on your own also. Like we have converted only this, what we were storing count, we have just converted this count or stored this count in this DP vector, and some of the sum up to get the final answer. So I hope I would have been clear to you. If still not, then you can go with the code and try on your own. This was not basically the harder problem to go through much deep inside. Okay, thank you. Radhe Radhe.